Hi, algebra. This isn't probably going to be your favorite chapter because our section because we're going to be back to graphing. Um, so graphing square roots functions. Objectives are going to be to graph square roots, to translate graph square roots functions. Okay. I think I do each one of these almost separately. Okay, now, square root functions. A square root function is a function that contains a square root and the independent variable in the radicand. The parent square root function y equals square root x. This table kind of shows what they kind of did there, just trying it out. And graph below shows the parent square root function. Okay. Finding the domain of a square root function. What is the domain of the y equals 2 square root this? So you have y equals 2 square root 3x minus 9. Okay. Well, the domain, we're going to set this equal to 0. Okay. This is all in the square root. So we'd have to minus or divide by 2. Divide by 2, you're going to end up with square root of 3x minus 9 equals 0 still. Oh, that's another thing to think about. Being this is in a radicand, or let's go to the other side. Being this is equal to a radicand at this point and it's 0, you know this has to be greater than or equal to 0. It cannot be a negative number. Because if it's negative, you can't have negatives in your radicand when it comes out. Okay, you'd have to square both sides, so you'd end up with 3x minus 9 is less than or equal to 0. Add 9. Add 9. You end up with 3x equal or is less or greater than or equal to 0 or 9 now. Divide by 3. Divide by 3. You get x is greater than or equal to 3. And that would be your domain for this. Nothing can be smaller than that because then this and the radicand becomes 0. Okay, this one you have y equals square root of negative x plus 5. This is all in that. Okay, once again, this has got to be greater than 0. Okay, square both sides. You end up with negative 2x plus 5 is greater than or equal to 0. Okay. Minus 5. Minus 5. End up with negative 5. Negative 2x. Divide by negative 2. Divide by negative 2. X equals, or x is greater than or equal to, these are both negative, so I'm going to change them both to positive and get 5 over 2. And move that up a little bit more. So since both of these were negative, I changed it to a positive. This can go in there. Anything larger than this will get me that. So anything above 2.5 will get me, or make this work so it's greater than 0. Which this has to be a positive number, otherwise it does not work. We learned that in an earlier section. Okay. Graph the function. I equals 1/5 square root P, which gives the current I amps for a certain circuit with P watts of power. When will it exceed 2 amps? So you got 1/2 square root 5, or square root P. Okay, P is going to equal, or P is going to be what you sub things in. This is like our X and Y chart here. Okay, so this is technically really an X and this is a Y. Okay, so if I put in 0 there, I'm going to get 0. Calculator handy, because it's going to be interesting to say the very least. We're going to try 10 right away. Square root of 10 divided by 5 is going to get you about 0.6. We're still a ways away. Let's try 50. 50, or square root of 50 divided by divided by 2. Or no, 5. My bad. Divided by 5 is 1.14. We're getting there. Okay, let's try 100. Once you get above it, then you can know you're in between these two numbers. Makes life a lot easier. Square root of 100 is going to be 10. Divided by 5 is going to get me 2. So, you could graph this to honestly, I'd only need this. This is going to be my amps. We'll go up by 0.5. So on this one, I'm going to go up with 10s, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, because we know 100 was 2. So that one's going to be right there. 10 we had is 0.6. Okay. 0 zeros here. 50 was 1.4. So it'd be right about there. So you'd have a graph that kind of looks like that, minus this little part right here. Okay, so you have a graph that looks like that. 2 would obviously have been your answer for that one. 2 or 100 amps, or not 100 amps, 100 watts or power is equal to 2 amps. Okay. Well, when will it exceed 1.5? Well, I wouldn't say it's going to take much after getting past 50. So if I was going to go type this into my calculator, into this formula, I would stay probably around 52. So you'd have to take the square root of 52 and then divide it by 5. You get 1.44. You need to be a little higher. So I'd probably try 53 then. Divide that by 5. You get 1.44. So I still got to be a little higher. Square root maybe 54 divided by 5. Still below it. Square root 56 divided by 5. getting very close. 57 divided by 5, and that gets us just over it. So we're in between 57 and 56. I'm trying to think. Actually, there might be an easier way to figure this out, but it wouldn't be by using a graph. By looking at the graph, though, you wouldn't have thought it would have been much over 50. Mine, anyway. So it'd be between 56 and 57. To get exact, it'd be 56.25. Yep. What you could have kept trying until you got that. I'm okay with being in between those two, because then at least I know you put in the work to figure that much out. What is the graph of a vertical translation? So this one, you have y equals square root x plus 2. So if you put 0 in there, you're going to get 2. You're going to, you put in 3 or 1, you're going to get 1, so you're going to get 3. 2, you get square root of 2. Square root of 2 plus 2 would get you about 3.4. So then you could graph that. Your x's, your y's. Probably just going to go up by 1, so you get 2 here. With 1 you get 3. With 2 you get 3.4. So you'd have something going on like this. Okay, basically what this vertical translation is showing you is this number adding on here is going to shift it one way or the other. If I had to guess, this one's going to be 3 below when you put it in. Well, if you put in 0, you're going to get 0, negative 3. If you put in 1, you're going to get 1 minus, so you get 0, negative 2. And if you put in 2, you're going to get you're going to get negative 1.5. So if you had to create a different, well, we can do it on the same graph. Okay, let's go down. You'd have 0, 3. My other point would have been negative 2, 0. Or negative, this was 1. So 1, negative 2. And then 2, about a half. So you'd have something that looked like that. That'd be your other one. What is the graph of square root x? And so this one's going to change horizontally, so you get y equals square root x plus 3. Okay. Once again, x and y's. 0 would give you 3, so that gives you square root of 3. 1 would give you 4, which would give you 2. 3 or 2 would give me 5, so that would give me square root of 5, and stuff like that. The other thing that could take place in this one, and I wasn't thinking along those, you could put in a couple negatives. You could get negative, or get a negative 1 there. You could get a negative 2. To get this to be 0, you would have had to put in 3. Honestly, so then you'd graph it, and what you'd see is by doing this, it created a shift. So basically, when it's under the radicand, this is going to move it over left and right. Being this was positive, it pushed it left. And this one up here, which we just did, you can see when it's outside, it's just going to move it up and down. This one moved it down, being negative. This moved it up, being so it was positive. That's about all you need to know today. Graphing is not your guys' favorite, but once again, you guys got a worksheet. Don't be afraid to get it on. Don't forget your flip grid.